All right, writing equations, chapter 2, beginning. Hopefully you guys are getting good at this. Let's go. All right, here's some main ideas and some vocabulary that we're going to go over here in just a second. We're going to skip that one because this one's bigger. So we're going to have a 4-step problem-solving plan. So first one's going to be explore, and we went over this last year, so hopefully you remember. Explore the problem. Now, I really liked underlining here. Underline the facts. When you get to that in any word problem, we'll do that. Then you plan to solve the solution, which is usually what formula or what, let's see, we'll get to formula in just a second. Either what formula or what concept, like the concept of the day, do you need to use? And usually if there's a word problem during a homework assignment, it's whatever that concept is that day. You're probably going to use the exact same steps. You just have to find the facts. That's why we underline them in the thing before. If it's on a test, you still got to find whichever concepts of that last chapter are going to be used. Solving the problem, that's the actual math. And then check your solution. Make sure it makes sense. You don't want to be 2 million miles away from the projector in the front of the room. It means you probably did something wrong. Or yesterday I had some people do, it was like 17.55. And I'm like, how did you get $17.55 when things were in 50-cent increments? So they messed up the decimal point and put it, as 5 cents instead of $5. So something like that, make sure it makes sense. So defining a variable is where you choose a variable to represent any one of the unspecified numbers. Probably your easiest one would be distance equals rate times time. So we would choose the variable d to represent distance. We choose r for rate, and we choose t for time. We're choosing a variable for that unspecified number. So a formula is an equation that states a rule or is a relationship between certain quantities. Probably your certain quantities, a good example of that would be, Fahrenheit to Celsius. They're related by a group of numbers that says, you multiply it by 2, you subtract 30. I don't remember what they were. That's just an example. Or that's a formula right there. Distance is related to rate times time. Same concept. All right, so we're going to translate this sentence into an equation. So a number b divided by 3 is equal to 6 less than 6. So I'm going to underline these to come up with my ideas of where or what goes with what. So a number b divided by 3 is equal to, and then 6 less than c. So, and I'm just kind of like is usually means equals, and these seem to be connected. This one divided by 3. So I would write those. You could spread them out. As I say, underlining is probably easier. Then I'm going to write on the left b over 3. B over 3 is going to be b divided is equal to is equal. 6 less than implies subtracting. Now be careful, just because 6 is written first in the words doesn't mean that's the order it goes. So if you'd gone 6 minus c, that would not be correct because you're taking away 6 from c. They say this one's not one that you can swap them and it becomes the same thing. All right, let's try this one. 15 more than z times 6 is y times 2 minus 11. Now I could do this whole, I could underline them all, but they're going to do it for us on this one. So I could spread them all out like this. 15 more than z. I'd have probably done like 15 more than z, and then times 6 is y times 2, and then minus 11, just to kind of connect them together. But this one, you just pretty much go straight across. 15 more than sounds like plus, z times 6 is an equal sign, y times 2, minus 11. They literally just wrote it out for us, which is beautiful. Oh yeah, and then your answer ends up looking like this. So your answer is inside of this kind of whole thing. Pause this, give it a shot. All right, so translate this way. A number, C, multiplied by 6 is equal to 2 more than D. So C times 6, I could either go C times 6, which is easier to write 6C, is equals 2 more than D. So either way works. You could go D plus 2, or you could do 2 plus D, because this is an interchangeable one here by those properties we learned in the last chapter. So 2 comes out to A. All right, translate this sentence into an equation. 3 less than a number, A, divided by 4 is 7 more than 3 times B. All right, so let's underline them out. So 3 less than a number divided by 4 is 7 more than 3 times B. So let's go 3 less than a number. So looks like they're using A, because they told us to, A minus 3, because 3 less than, so we're taking 3 away, divided by 4, put that over 4, is equals 7 more than 3 times B. So I could either write 3 times B. It'd probably be easier to flip this all the way around, and that's what it looks like they did over here. So it'd be 3B plus 7. Again, these are interchangeable, as in I can swap them. So this term and this term I can swap. So that's why I ended up putting this over here and this over here. And that comes out to C. Whoops, I was a little bit off there. So 3 less than a number, A, divided by 4. So that's why they put A over 4 minus 3. So it almost works kind of like PEMDAS. When you put them together, you need to put together the numbers, or put the multiplication and division together first, and then where do you put the addition? Will probably be a good way to go from on this. All right, so here's a little example of that 4-step plan. A jelly bean manufacturer produces 1,250,000 jelly beans per hour. Yum. How many hours does it take them to produce 10 million jelly beans? All right, so we first know that there's 1,200 and 1,250 jelly beans per hour. So I probably have underlined that. And we want to know how many hours, oops, that's a terrible underline, is it to produce that? Okay, so my plan is to write an equation. We're going to let H represent the number of hours needed to produce the jelly beans. So 100 times hours equals 1 million. This is kind of what we're going for. So how many hours? So we have to multiply 1,200 beans per hour. That's why we did multiply. So 1,200 beans per hour, 1,200 times hours equals 10 million. So we put that into an equation like this. We divide both sides by, oh, they're going to reduce it first. That's fine. So what number times 125 equals 1,000, which would be 8. Or you could just divide over, which is what I probably would have done in your calculator. So it takes approximately 8 hours to produce that. Yeah, that makes sense. All right, same basic concept. You try. All right, so a person at Keytronics World Invitational typed 148 words per minute. Man, I need this for my computer apps class. 148 words per minute. How many minutes would it take them to type 1,354? All right, so this person types 1,400 words per minute. How many minutes would it take to type 1,400 words? So I do 148 times minutes per minute equals 3,552. And I'm just going to divide both sides by 148. Punch those into my calculator. Let's see, 3,552 divided by 148 equals 24. D. Moving on. All right, write a formula for this. Translate this sentence into a formula. Perimeter of a square equals 4 times the length of one side. So we start out with the perimeter equals 4 times, perimeter equals 4 times the length of the side. So we're going to have P for one variable, and it looks like S for the length of the side. So perimeter equals 4 times the length of the side. So P equals 4S. And we probably would have started with 4 times S and then converted it into that. And there's your formula. P equals 4S. Pause this. Hopefully you didn't see that. Give it a shot. All right, translate this sentence into a formula. It's the area of a square equals the product of pi and the square of the radius r. All right, so the area of a square equals the product of m and the square of r. So the area, A, equals the product of pi and the square. Now, product means they're all going to be multiplied, and the square of the radius r. Pi r squared. And we'll get to that later. All right, translate this one into a verbal sentence. We're going backwards now. Okay, so spread them all out seems like an easy way to do this. So 12 minus 2 times the number x, or 2 times x, equals -5. Seems fairly simple enough. 12 minus 2 times x equals -5. Translate this one into a verbal sentence. Okay, so I think they're going to spread it out again. I really like this concept, so you probably do this on a separate piece of paper when you get to your homework. So the square of a, or a squared, plus 3 times b equals c divided by 6. See how close I am. A squared plus 3 times b equals c divided by 6. I don't think that was verbatim. Beautiful. Pause this, give it a shot. All right, so let's translate this one in here. So we'd spread it out first. So 12 over b minus 4 equals -1. So 12 divided by b minus 4, I don't think I spelled that right, equals -1. 12 divided by b minus 4 equals -1. I love it. Try this one. So 5a equals b squared plus 1. You could also just read it straight across too. So 5 times a equals b squared plus 1. 5 times a equals b squared plus 1. All right, write a problem. This one could be a little more complicated, and that's all right. Running low on time, got to go quick here. So, cost of fries equals the cost of the burger. So 4 times this minus the fries equals $8.50. So it looks like the cost of a burger is $1.50 more than the cost of the fries. 4 times the cost of a burger cost of fries equals this. How much do the fries cost? A little complicated. So really, I'm just looking at this and I'm trying to find the cost of the burger. 4 times the fries, the cost of fries plus $1.50 minus the fries equals 8. $2.25. How much are the fries? And I'll even be nice and let you skip this.